Hi, everybody. All right, so we are going to get started on going over this review. In review videos, just so you know, I do kind of go through them a little bit quicker because it is a review. So I'm not teaching you the material necessarily. So if it is going through too fast, please reach out and I can still help you in other ways. But this does give you a chance to watch me go through the video and to answer the question so that you can see me doing it to see where maybe you made your mistake or to just help you. Remember, you can skip through this video and it is not mandatory. All right, so the first question is simply 14 over 5 minus 4 over 5. The first thing that you should be doing when you're seeing fractions in an operation is you should be identifying what is our operation. Because when we're multiplying or dividing versus adding or subtracting, there's a huge difference in the way that we're solving this. Once we see it's adding or subtracting, then the first thing we do is we say, okay, let's look at our denominators. Are they the same? And yes, they are. So once they're the same, that means that we don't need to worry about manipulating or changing our fractions, and we can simply just perform the operation that is in our numerator. So we can then do 14 minus 4 over top of 5. So 14 minus 4 is then going to be equal to 10. So we now have 10 over 5. If you left your answer like this, you're not receiving full credit because with every fraction, we need to simplify as much as we can. So remember, this one is easy and can be done in a few different ways. Fraction bars represent division. So we can look at this as 10 divided by 5, and we know that 10 divided by 5 is 2, so I know that this is going to be equal to 2. Well, another way you can think about it is when we're simplifying our fraction, we're seeing what number divides evenly into both our numerator and denominator, and they're both divisible by 5. So that would give us also to 2 over 1 or to just 2. All right, now let's move on to the next question. All right, so the same thing, we see fractions and operation that's being done with them. What is that operation? It is minus. So now we go ahead and we say, okay, since we're adding and subtracting, our denominators are the same. And once again, they are. So it's set up nice and easy for us to just perform our the computation. So it'll be 11 minus 5 over 12. Well, we know 11 minus 5 is 6, so now we're left with 6 over 12. Once again, if you just left it like this, you're going to get partial credit and not full credit. So now we look and say, okay, are there any numbers that are divisible into both 6 and 12? And yes, they are both divisible by 6. So I will divide 6 by 6, which I know is going to be equal to 1, and I will divide 12 by 6, which is going to be equal to 2. So our final answer for this question is 1/2. All right, so same thing. You're going to hear me say this all the time. But we're dealing with fractions. What is our operation? In this case, it's addition. So we look at our denominators. Are they the same? And no, they're not. And in order for us to add or subtract fractions, we need to have our denominator be the same because we need to be looking at its equal parts. Because when something is broken into fifths versus something broken into eighths, if I trade it with you, we're not trading equally. So if I broke my candy bar into half and you broke your candy bar into thirds, it wouldn't be fair for me to give you one of my pieces for one of yours because mine will be bigger since they're broken into halves, where yours will be smaller since they're broken into thirds. So we need to go ahead and make sure that we have like denominators. So what we can do is off to the side, if you want to, you can go ahead and you can write out all of your multiples for your two denominators until you get to your least common multiple. So I'm just going to just go to the number that I know that it is. So 8 and 5, our least common multiple is going to be 40. So in this case, we say, all right, we know it's going to end up being 40. So what do I need to multiply 5 by to get to 40? And that is going to be 8. And what we multiply by our denominator, we also have to multiply by our numerator because I know 8 over 8 is equal to 1. And since this fraction that we're multiplying by is equal to 1, I know I'm not changing the value. 2 over 5 is equal to 0.4. And when we multiply this, we get 8 times 2, which is 16, and 8 times 5, which is 40. If you plug this into your calculator, 16 over 40 is also equal to 0.4. So no matter what, you will get the exact same value for our decimal. So it's telling us that by multiplying by 8 over 8, we're not changing its value, but we're manipulating it so that we can have our fractions be broken into equal parts. And then I look at the other fraction and say, okay, well, what do I need to multiply 8 by to get to 40? And that's going to be 5. So I multiply both the numerator and denominator by 5. So now I get 3 times 5, which is 15, 8 times 5, which is 40. And then now that we have common denominators, we can go ahead and we can add or subtract our numerator, whatever it is. In this case, we're adding. So then we get 16 plus 15 over 40, and 16 plus 15 is equal to 31. So our final answer will be 31 over 40. And we always try to reduce, and since 31 is a prime number, I know that it can't. All right, same thing. We see that we're subtracting, so we know that we need to look for common denominators. We need to have our fractions be broken into equal parts, 8 and 12. If you're not sure what the common denominator or least common multiple is between them, we can go ahead and we can write out our multiples, 8, 16, and 24. When I see 24, I know 12 goes into 24, so I'm going to check and see, okay, is that our least common multiple? Well, I have 12 and I have 24, so yes, they both go into 24, and that's the smallest number to go into. If you use a larger number, that's fine. It's not the end of the world. You'll still be able to get it right. The difference is you're going to have to simplify at the end versus if you're using the least common multiple. All right, so then we ask ourselves, all right, so we know it's going to be 24. Well, 8 times what is 24? Well, 8 times 3. So I know I need to multiply both of those by 3. 3 times 5 is going to give me 15, and 3 times 8 is 24. So the same thing, if you plug 5 over 8 and 15 over 24 into a calculator, you'd get the exact same value. And then we look and say, all right, well, what do I need to multiply 12 by to get to 24? And that's 2. So now I'm multiplying by 2 over 2. So now 7 times 2 is 14, and 12 times 2 is 24. Now that we have our same denominator, we can go ahead and write these and combine these fractions and actually perform the operation. So it would be 15 minus 14 over 24. And then this will simplify, or 15 minus 14 is going to be 1. So it'll be 1 over 24. Obviously, this can't reduce anymore because 1 doesn't have any common factors besides this itself. So that would be our answer, 1 over 24. All right, same thing. We're looking at our denominators because we're adding. So since we're adding, we need common denominators. They are not the same. So I'm just going to jump to this because I have showed you in the last few ones of how you can find your common denominator if you need to, or your least common multiple. So I'm just going to go ahead and jump straight to this. So in this case, we have 2 over 7 plus 3 over 8. Well, I know that my least common denominator in this case is going to be 56. So because we can always just multiply the two denominators anyway to get whatever one is, but since 7 is prime, I know the only time that they're going to share a factor or a multiple is when we multiply them together. So 7 times 8 will give me 56. So then I will go ahead and say 8 over 8, and this one is going to be 7 over 7. So now we will multiply. 8 times 2 is 16 over 56, and 3 times 7 is 21 over 56. Now that we have the exact same denominators, we can go ahead and combine these. So let's add these together. So we get 16 plus 21 over 56, and this is going to be equal to 37 over 56. Since 37 is prime, I know that this is going to be its simplest form. Final answer. Okay, question number 6, 5 over 7 minus 7 over 11. Same thing, we need to find common denominators. And since 7 and 11 are both prime, I know that my common denominator is going to be when I multiply them together. If you don't know that, as I showed you in your first couple questions, please just write out all of your multiples for 7 and 11. So in order for me to get to 77, I would have to multiply 7 by 11, and I'd have to multiply 11 by 7. So now I'm going to go ahead and multiply. 11 times 5 is 55. So now we get 55 over 77 minus 49 over 77. Well, now that we have the exact same denominator, we can go ahead and combine our numerators. So we get 55 minus 49 over 77. And we know that 55 minus 49 is equal to 6. So we get 6 over 77. And that will be our final answer, because I know that there's no number that divides evenly into 6 and 77, because the only factors of 6 are 2 and 3, and the only factors of 77 are 7 and 11. And since they don't share any, it can't reduce. So you always have to get in the habit, though, of thinking, can it reduce? Can it reduce? Is there any number that goes into both of them? I gave you all of your rules on how to know if a number is divisible by something. So you do need to know those, all right? Because if you don't simplify, you're not getting full credit for your question, and you're only showing me that you partially know how to add and subtract your fractions, or even multiply and divide your fractions. So you're not going to be able to get proficient if you can't do it in its entirety. All right, let's go ahead and move on to the next question now. All right, so now we have 2 over 6 times 3 over 5. So now we're finally doing something that's different than adding and subtracting. When we're multiplying, we do need to make sure that we are, or that we're not, finding common denominators. All right, we don't need common denominators when we're multiplying. When we multiply, we simply just multiply. All right, I'm going to show you one way to doing it. But as I said before, you guys can use any method you want. I personally think it's better if you start reducing first before you multiply, because your numbers are smaller and it's easier to see what factors they share versus when you have these really big numbers after you multiply. So what I like to do is when we multiply two fractions, we can rewrite them on the same fraction, meaning I can just multiply my numerators, because that's what we do when we're multiplying. We simply would multiply them. But rather than multiplying them, I'm going to just write it as 2 times 3. I'm going to keep it in its factored form, or in the two numbers being multiplied. And then I'll do 6 times 5. Rather than straight going to 2 times 3 is 6 and 6 times 5 is 30, I leave it like this. And the reason is I look to factor or simplify first. So I look at my 2 and I say, okay, does 2 share any common factors with any of the numbers in my numerator or my denominator? It could be 6 or 5. It doesn't matter. It doesn't just have to be the one that's directly below it. It could be either of the ones, as long as if you're comparing numerators and your denominators, or tops and bottoms. So 2 goes into 2 one time, and 2 goes into 6 3 times. So I'm reducing those factors by the same number 2, because they're both divisible by 2. And now I'm saying, okay, well, 2 just reduced to 1, so I can't do anything else with it. So let me go to my next number. So now I'm looking at this 3, and I'm saying, okay, now does 3 reduce with my new number after reducing my 6, or my 5? Well, of course, 3 will reduce with 3, because they both shared a factor of 3. So 3 goes into 3 once, and 3 goes into 3 once. So you see now I'm using these two different colors to show you where the numbers are actually being reduced with. So you can see I've reduced the greens with the greens and the reds with the reds. And now I can go ahead and multiply what is left over. And what is left over is this 1 times this 1. Well, we know 1 times 1 is going to be equal to 1. So I'll say 1. And now we have this 1 times 5, which we know 1 times 5 is 5. So our final answer is 1 over 5. If you jumped straight to the multiplication and got 6 over 30, you still would have gotten 1 over 5, because you would have reduced 6 over 30 by dividing each of these by 6 and got 1 over 5. So it doesn't matter which way you do it. I'm only going to stick to showing you one way right now in this review video, just for interest of time, and just because I do think this is the better of the two ways. So I'm going to show you this, but you do whatever way you prefer. All right, so now we're left with 5 over 10, or now our next problem is 5 over 10 times 4 over 5. So since we're multiplying, it's easy in the sense that we don't have to think about anything. We can just straight multiply. So now we're going to do 5 times 4 over 10 times 5. All right, so now we're just simply bringing our fractions together. And now I'm looking at my numbers again. I'm saying, okay, I'm starting with 5. Does 5 share any factors with 10 or 5? And it does share it with both, but the thing is you can't reduce both. You can only reduce it with one of them. So you pick one, whichever one you want to do. I'm going to simply reduce it to 5 since they're the same number, and it's easy, and there's a little bit easier, and there's no really thinking it goes into it. 5 goes into 5 one time, and 5 goes into 5 one time. But you could have picked a 10 if you wanted to. There's no right or wrong reason for that. Right? Then I move on to the next one. Can 4 reduce with either the new number 1, which it can't, or 10? And yes, 4 and 10 can reduce. They're both even, so I know they're both divisible by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. So now I'm left with 1 times 2. I'm left with 1 and 2. So 1 times 2 is going to give me 2. And I'm left with 5 times 1, which is going to give me 5. So my final answer is 2 over 5. Okay, now on to question number 9, where now you see our operation is back to adding. So now we're no longer, sorry, I wrote this question wrong. It's 2 over 8. 2 over 8, not 2 over 3. So we're adding. So now it's not just, okay, we can just add what we want. We need common denominators. We need them broken into the exact same pieces or parts. So in this case, we already did where we know 5 and 8 have their least common denominator is 40. So I'm going to go ahead and say 8 over 8, we will need to multiply this fraction because our least common denominator is 40. And this one here, we would have to multiply by 5 over 5. Well, 3 times 8 is 24. So now we have 24 over 40 plus 2 times 5 is going to give me 10 over 40. And now that we have the exact same denominator, we can go ahead and we can combine our numerators. So in this case, we will have 24 plus 10 over 40. Now, you don't have to show me this step. I'm just showing you what we're doing. I'm showing you it rather than skipping. I'm showing you everything that we do. So 24 plus 10 is equal to 34. So now we have 34 over 40. Well, just the other ones, whenever we add it, subtract it, none of them ever reduce. So it's like, okay, it's our final answer. But no, we have to see, can they reduce? And hopefully this jumps out at you that they're both even numbers. And since they're both even, we know that it can be at least divisible by 2. So I'm going to go ahead and divide each of these by 2 just to start reducing my number. And 34 divided by 2 is going to be 17. 40 divided by 2 is 20. And since 17 is prime, I know that I can't reduce this anymore. right? There's no number that can go into both 17 and 20, so this will be my final answer. Okay, so for this problem, we have 9 over 10 times 35 over 3. We see times. Times are probably the easiest of the problems that we do with fractions. Even though it might generate these really large numbers, it's the easiest because it's the less amount of thinking we have to do. We can just go straight to it. So we can go ahead. All right, so now we can just go ahead and just straight multiply across. So we do 9 times 35 over 10 times 3. I actually think it is better, even if you're going to reduce. I see a lot of you reducing when it's just written as separate fractions. It's perfectly fine. But if you're getting used to this, I do think it's better to put them under one fraction. So that way you can kind of think about them a little bit easier. So we just start with our 9. And we say, okay, does 9 share any common factors with 10 or 3? And yes, 9 and 3 both do. So I can divide each of them by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. And then I see, can 3 divide evenly, or does it share any other common factors with any of the other numbers? And no, it doesn't. So we know we can move on to the next one. 35. Well, it can't share anything with 1 because 1 doesn't have any other factors but itself. So we look at the other one, 10. Well, if a number ends in 0 or 5, we know that they're divisible by 5. So we know that they do share a common factor of 5. So we'll divide it out. So 35 divided by 5 is 7, and 10 divided by 5 is 2. And now we say, okay, well, 7 and 3, they don't have any common factors with 2, so we're done simplifying. So now let's go ahead and multiply across. Well, we have our 3 times our 7, which is going to be equal to 21. And we have our 2 times our 1, which is going to be equal to 2. So our final answer is 21 over 2. All right, this is a good example of showing you why I think it's better for you to simplify first, because if we were to multiply and we do 9 times 35, let's see, 9 times 30 is 270. 270 plus 45 is 315 over 30. So yeah, this one might jump out at you because you see it ends in a 5 and 0, so you know that they're both divisible by 5. But 315 is a large number, and for you to go through all the factors of 315 to see what you can reduce, that could take a long time. So that's why I think doing it first is better, because we're dealing with smaller numbers. It's the only reason why I suggest it. But you do whichever way you think is best for you. All right, so now we see 4 over 7 divided by 3 over 4. So now we're finally doing something different than this adding, subtracting, multiplying. Now we're doing dividing. All right, and with division, we have a rule that we have to do first. Division ultimately ends in multiplication. So ultimately ends in an easy problem. But we have to make sure we do one thing first. And before we do that, let me just go ahead. If I have one candy bar and I'm like, okay, I'm going to divide this candy bar by half. So I'm going to divide it by half. How many pieces will I actually create by dividing it by half? Well, if we divide it in half, it's going to create 2 pieces. So I know 1 divided by 1/2 is 2. So now with the same thing, I'm like, okay, instead of dividing this candy bar by halves, I'm going to divide this candy bar by thirds. Well, how many pieces do I generate now? I'm going to generate 3 pieces. So we have 1 divided by 1/3, we know it's going to be equal to 3. So if you notice, when we're dividing by this fraction, it's less than 1, especially, but when we're dividing by this fraction, 1 divided by 1/2 generated 2. 1 divided by 1/3 is equal to 3. And the reason is when we're dividing by that fraction, we need to multiply by its reciprocal. Right? There is a rule that you're going to hear me say, and when I say this, I always, I'm going to play you guys a video later on, which is like this rap video that goes over this. So it's keep, change, flip. Yeah, that's the action. Everybody knows how we're dividing fractions. So I say this all the time. Our first one is keep, we change, and we flip. So what that means is the first fraction does not change at all. It stays exactly as is. So 4 over 7 gets written as 4 over 7. And then we change. We change the division to multiplication. And then we flip. We take the reciprocal of our second fraction, what we're dividing by. And when we take a reciprocal, you say you love me, but now you flip them like reciprocals. Or we can flip it and it becomes 4 over 3. And once you do that one step, it just turns into a regular multiplication problem, which we just went through, and it's very easy. It's simple in that there's really no thinking. We just go ahead, we multiply our numerator with our numerator, and we multiply our denominator with our denominator. The hard part about this is making sure that we reduce. Well, both of our numerators are 4, so we don't really have to think too hard about this. Does 4 have any common factors with 7 or 3? No, 7 and 3 are both prime numbers, so none of them go evenly into 4, so that means that all we need to do is just simply multiply. 4 times 4 is 16, 7 times 3 is 21, and bam, that is our final answer. And since it couldn't simplify in the beginning before we multiplied, we don't have to look at it at the end, because if it couldn't simplify before, it can't simplify after either. That's another reason why I think doing it first is better, because once we get these large numbers, if they couldn't reduce beforehand, then we know it can't reduce after. So it actually makes our life a little bit easier. All right, our next problem, we have 8 over 9 divided by 12 over 18. Same thing. Okay, we see division. Don't forget your first step. Keep, change, flip. Yeah, that's the action. Everybody knows how we're dividing fractions. So we're going to keep the first fraction exactly as is. So it's 8 over 9. We change it to multiplication, and then we flip our second fraction. We take its reciprocal. You say you love me, but now you flip them like reciprocals. So now it's 18 over 12. Then we're going to multiply. So we're just going to put these under the exact, or we're just going to put them on the same fraction. 9 times 12. And then we're going to go ahead and reduce. I'm going to look and see, okay, does 8 share any factors with 9 or 12? Yes, it does with 12. And 4 goes into it. 2 does as well, but we want to take the largest of that common factor. And if you did 2, you would see that you could do it again, which it's not. It's okay. It's just going to take you maybe a little bit longer. But 4 goes into 8 twice, and 4 goes into 12 3 times. And then we look and see, okay, 2 doesn't go in with 9 or 3, so then we look and see, does 18 share any common factors with 9 or 3? It shares it with both, but I'm just going to pick, remember, you can only pick one. I'm going to pick 9 because I know 9 goes into 18 evenly, and 9 goes into 18 twice, and 9 goes into 9 once. I picked 9 because since I knew 9 went into 18, I know it's going to end up just giving me a 1 at the end, so it's going to be easy for me to do any calculations I need to next. And then there's nothing else that goes into these because we have all prime numbers. So now we have 2 times 2, which is going to be 4, and 1 times 3, which is going to be 3. All right, you do not have to write your answers as mixed numbers or mixed fractions. You can leave them as improper. I actually will suggest you start leaving them as improper fractions because none of our standards directly say that you have to do it and go back and forth. And you'll see once you start getting into higher level maths, we leave them as improper fractions when we're doing our calculations. All right, so that will be it for this problem. Okay, we have 5 over 4 divided by 15 over 12. We see the division, so the first thing that we're going to do is we're going to keep, change, flip. Yeah, that's the action. Everybody knows how we're dividing fractions. So we keep, we change the multiplication, and we flip. All right, now that we have it written as a multiplication problem, we go ahead and we just write them on the same fraction. We just perform the multiplication, but before we do that, we're going to look to reduce. Well, 5, does it share any common factors with 4 or 15? Yes, it does with 15. 5 goes into 5 once, 5 goes into 15 3 times. So we're going to move on to the next one because we can't reduce any more with 1. So we do 12. Well, does 12 share anything with 4 or 3? Yeah, it does with both, but let's do one at a time. Let's do 4. So 4 goes into 4 once, and 4 goes into 12 3 times. And then I say, okay, well, 3 and 3, they obviously share a common factor of 3, so they both divide into each other one time. So now I'm left with all ones. Well, that's easy. 1 times 1 is 1. 1 times 1 is 1. Do not leave your answer as 1 over 1. I won't take off any points if you do that, but we always want to simplify everything as much as we can. And anytime something's being divided by 1, we know it's just our whatever number we're dividing into. So 1 divided by 1 is equal to 1. So you don't need to leave it as a fraction. You can go ahead and write it as 1. The same thing, if you were to get 5 over 1, I would want you to write that as just 5. You don't need to leave it as a fraction and write it over that 1 because every whole number is understood to be over 1. All right, now we have 3 over 10 plus 6 over 8. So once again, it's not multiplying or dividing, it's adding or subtracting, so we need common denominators. And 10 and 8 are not common denominators. So I'm going to just jump to the number that is, or I'll show you guys again. So we have 10, so we have 10, 20, 30, 40. Well, I know 8 goes into 40, so I'm going to say, okay, let's just see if there's any other ones. But this is how, remember, you can go ahead and see what our least common denominator is. If you don't know them off the top of your head, just simply write out all of your multiples for both numbers until you get one that is the same. So 40 is the same for both of them. So I'm going to say, okay, well, 10 times what is 40? So that's 4. So I know I'm going to multiply it by 4 over 4. And 8 times what is 40? That's 5. So I know I'm going to multiply by 5 over 5. Well, 4 times 3 is 12. And 4 times 10 is 40. And then we go ahead and do the other one. 5 times 6 is 30. And 5 times 8 is 40. So now that we have our common denominators, we know that these are now broken into equal parts. So that means that each of these numbers in our numerators equal or represent the same amount, if you want to call it that, for each piece. So now we can combine or add our numerators of 12 plus 30 over 40. Well, here we know that 12 plus 30 is equal to 42. And now we have 42 over 40. So we say, okay, can we reduce? Well, they're both even, so we know that they can both be divisible by 2. So let's just do it with the easiest and see if that's our final answer. Well, 42 divided by 2 is 21. 40 divided by 2 is 20. There's nothing that goes into 21 that goes into 20. So that is our final answer. All right, so for this video, I'm going to alternate between the different methods that I showed you in the other video. So some people might stack them, some people might do the boxes, but I'm going to alternate it. I probably will suggest that you use the stacking on the assessment on Monday, because you guys are going to be drawing, writing out with your computer mouse, and it's not the easiest to write, and trying to draw the boxes could get a little sloppy. So I probably would suggest that you do the stack, but it's your call, obviously. So we would do 72 times 36. So we line them up and put our ones over our ones or tens, etc. So now we just start with our ones here and we multiply. So we do 6 times 2, which is 12. So then we can go ahead and put the 2 for the 12 and we carry the 1. 6 times 7 is 42, plus 1 is 43. So now we go ahead and we move on to our next number. So we're on our tens. And I know 10 times any number will only be a minimum of tens. So that means we can't have any ones go here anymore. So you must put your 0. A lot of you are forgetting to do that. So don't forget to do that on this assessment. 3 times 2 is 6. And 3 times 7 is 21. So now that we multiplied all of our numbers, we can simply add down. And 2 plus 0 is 2. 3 plus 6 is 9. 4 plus 1 is 5. And 2 is just 2. So our final answer is 2,592. All right, our next problem we have is 49 times 97. I know I just said in the last one I was going to alternate. Since I'm decided that you guys should just use the stacked version, I'm just going to do the stacked every time, just because if you're not going to use the other version on this assessment, we can practice that later on. So we stack them, we multiply 7 times 9, which is 63, so we put our 3, we carry the 6, then we do 7 times 4, which is 28, plus 6, which is 34, and now I'm going to cross this out because I used it. So I'm going to move on to the next number. Since it's a tens, I know I need to put my 0. 9 times 9 is 81. And now 9 times 4 is 36, plus 8 is 44. And now I'm going to go ahead and add these down. This gives me 3, 5, 7, and 4. So my final answer is 4,753. Okay, we have 251 times 35. So we'll do 251 times 35. You don't necessarily have to put the larger number on top, but normally I always do that. Just makes it, I don't know, when you have less numbers that you're multiplying like by 251, that means it's less times that you have to put the zeros for your placeholders, less times for you to make a mistake. So I just always suggest putting a larger number on top like that, but you don't have to. But now we just go ahead and we start with our 5. We multiply. 5 times 1 is 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. We move on to the next digit. We put our 0 because now we're at tens. 3 times 1 is 3. 3 times 5 is 15. We carry the 1. 3 times 2 is 6, plus 1 is 7. Now that we multiplied everything out, we can go ahead and add down. This gives me 5, 8, 7. 5, 8, 7, and 8. I almost did it again. So now we have 8,785. All right, same thing here again. We're going to write them on top of each other. We're going to put the larger one on top. So now we're going to multiply. We start with our first digit, our 1. So 6 times 2 is 12. We carry the 1 because it's the 10, so it's going to the tens. 6 times 4 is 24, plus 1 is 25. So then our hundreds, we will then carry the 2. 6 times 8 is 48, plus 2 is 50. And now we're going to go ahead and move on to our 5. Remember, now we're at our tens, we need to put our 0. So 5 times 2 is 10, so we 0, carry the 1. 5 times 4 is 20, plus 1 is 21. And 5 times 8 is 40, plus 2 is 42. Now we're going to go ahead and add these together. So we get 2, 5, 1. Well, that was really easy. We didn't have to add anything. 7 and 4. So then our final answer is 47,152. All right, we have 516 times 83. So now we're going to multiply, same thing. We start with our 1s. 3 times 6 is 18. So we're putting the 1s down, carrying our 10s. 3 times 1 is 3, plus 1 is 4. So 5 times 3 is 15. I'm going to cross this out because I used it. Now we do 8 times 6. Well, before we do that, we're moving to our 10s. So we got to put our 0. 8 times 6 is 48. 8 times 1 plus 4 is going to give me 12. And 8 times 5 is 40, plus 1 is 41. And now we're going to go ahead and add down. This gives me 8. This adds up to 12, so I need to carry the 1. This gives me 8. This gives me 2 and 4. So then our final answer is 42,828. All right, now we're moving on to the last question. All right, so this one was a word problem. It says Carson brought 7 over 8 pounds of cans in for recycling. Last week, he recycled 5 over 6 pounds of cans. how many more pounds of cans did Carson bring in this week than last week? So we want to know how much more did he bring in this week than last week. So that means in order for us to figure out how much more we did this time, we need to subtract what we did this time with what we need to subtract what we did last time from what we did this time to figure out, well, what is the difference and see how much more we did. So the way that we would set this problem up is 7 over 8 minus 5 over 6. All right. Then when we go ahead and to try and solve this, we need to figure out what their least common multiple is. So 8 has 8, 16, 24. Well, hopefully you know that 6 goes into 24 as well. So we can go ahead and move into the next one, 6, 12, 18, and 24. So to multiply or to get to 24, 8 would have to multiply. Let me just erase this. 8 would have to multiply by 3. So multiply by 3 over 3. And 6 would have to multiply by 4 over 4. So now we will get the number of 21 over 24. Minus 5 times 4 is 20 over 24. And now that we have the exact same denominators, we can go ahead and write these, perform the operation with the numerator. So it's 21 minus 20. And 21 minus 20 is going to be equal to 1. So now we get 1 over 24. Final answer, the end of this review. All right, if you need any help with anything, please reach out.